Hello folks, we come to the exercise 11.3 and this is the part 1 video for this exercise. As we had seen that throughout this exercise we are going to take the double cone and the double cone getting intersected by a plane and the different sections that is generated out of it. We already have seen the circle and we have seen the parabola. Now today's thing we are going to see the ellipse. The ellipse is nothing new to you, a shape like something like an egg shaped thing. Yeah, that's the ellipse. It's flat version. That's what is the ellipse. And the ellipse they are not like parabola. It has only of two types. Parabola we saw it is of 4 types, but this ellipse is only of 2 types. One is like this, which is flattened over here like this, and the other one is flattened over the y-axis like this. So these are the 2 types of ellipses that you are going to see. This ellipse will have the equation x squared by a squared plus y squared by b squared equal to 1, where what is this a and b? This distance is what is a and this distance is what is b. Obviously a is always going to be bigger than b, and that is why wherever a is placed, that is called as a major axis because it's big, and wherever b is placed, that is called as a minor axis. Okay, so in this case the equation will become x squared by b squared plus y squared by a squared equal to 1, where you have this a going to the place where it's like, because y is major here, a will go there. That's the meaning. So in this case the major axis is the y axis, the minor axis is the x axis. So this is about the ellipses. What we have to do in the first 9 problems is like what we did in the parabola. The equation will be given to us. They ask us several things and I have written out a formula for everything. So you just have to substitute in the formula, get the answer. That's all, depending on these 2 ellipses that is being given to us. So I think we can start right away and see how these things can be done up with. You have the first problem which says that is x squared plus 36 plus y squared. Actually, what is the meaning of this? This ellipse is like this, it's this way. 36 means it will be 60 here, and it will be minus 60 here, and it will be 40 here, and 04 here, 0 minus 4 here. Yeah, that's you are taking the root of it. 36 6, so here it is 6, and this is b actually, and that b is square root is 4, so 4 over here. That's the meaning. So this is how the ellipse is going to look, and let's quickly locate this here. A squared is 36 and b squared is 16. This is the meaning of this statement, and therefore the a becomes 6 and the b becomes 4. Wherever it is required, we will use it. Now c squared is something that you should always find because that is useful for all the other things that you have to do. So c squared is something that is a squared minus b squared in this case. So a squared for us, it's 36 minus 16 comes to 20, like that c comes to root 20. That will help you to get the foci. Foci is the point over here, properties etc. we study in the theory. Okay, so the foci is plus or minus c0 in this case, so it is plus or minus root 20 comma 0. We know it is lying on the x-axis, right? This is lying on the x-axis, it's of this type. Then vertex is also on the x-axis, so it's of the type plus or minus a0. A for us is 6, so plus or minus 60. Major axis, length of the major axis means this much distance. How much it is, that we have to find. So it is 2 into a by formula, so it is 2 into 6 12, and 2 into b, length of minor axis, this much distance, so that is 2b by formula, that is 2 into 4 8. Then e is eccentricity, which is by formula c by a, and c for us here it is root 20, a for us it is 6. So we can have it like that. If you want, you can solve it like root 20 is 4 into 5, so 2 can come out, and like that you can solve it, or this is broadly the answer. The length of the lattice rectum is 2b squared by a, so 2b squared for us is 16. 2 into 16 by a for us, it is going to be 6. So you could have 2 3s, answer is 16 by 3. Overview, yes, more or less right. So that is about the problem number 1. Quickly let's go to the problem number 2. If you carefully see that it is below y that the bigger value is coming. You should see where that bigger value is coming. Depending on that, you can tell which kind of ellipse it is. So it is below y that the bigger value is coming, so it's of type 2. So it is like this. This ellipse is like this. Like this, where this will be 5 0. I'll write only one side, so you can predict the other side, and this will be 2 0. How we got this? By taking the roots of this. Okay. Now From here, the bigger value is a squared always, and the smaller value is b squared. So a will become 5, b will become 2. Okay. So in order to get the c squared value, it is a squared minus b squared. So 25 minus 4, it is 21. C becomes root 21. Like that, you will get the value of focus. But because this is the major axis on the y-axis, it will go to 0 plus or minus c. So it will be 0 plus or minus root 21. Here also it will be 0 plus or minus 5. And here it is 2a, which is 10, 2b, which is 4. And c by a eccentricity, c is root 21, a for us is 5. And then length of lateral rectum 2b squared, that is 2 into 4 2b squared by a for us is 5. So that is 4 to the 8 by 5. Overview, yes. So that is how the problems go. You have those ready-made formulae, you just have to trace what kind of ellipse it is, then put it in the relevant formula and get the answer, that's all. So you have now this, whether it is of type 1 or type 2, it's of type 1. Type 1, so it is like this, it is of type 1, something like this, where you could have this as 4, 0, you are taking the root, and this is 0, 3. And major axis is the x-axis. So you have a squared as 16 and you have b squared as 9, which gives the a value as 4 and which gives the b value as 3. And that way c squared is a squared minus b squared, which is 16 minus 9, which is 7. And because the foci is on the x, c will be root 7. Foci is on the x-axis, plus or minus root 7 comma 0. Vertex is plus or minus 4 comma 0. 2a, so 8 and 6, 3 2s are 6, and then c by a, that is root 7 by 4, and then 2b squared by a, so 2 into 9 by 4, so that is 9 by 2. These are all lengths, so and so units actually, yes. That's about the problem number 3. Problem number 4 again, because beneath y the bigger value is, so it is of type 2. So it's like this, it's of type 2 because you have the bigger value beneath the y. So it is like probably here it is 5 comma 0 and here it is 0 comma 10, like that. So the a squared for us, it is 100, that makes a value as 10, and the b squared here is 25, that makes the b value as 5. That way you can get the c value, that is a squared minus b squared, 100 minus 25, which is 75, and c value therefore becomes root 75. So you have the focus, it's on the y, so the focus will be 0 plus or minus root 75, and you can also have the vertex, which is 0 plus or minus a, 0 plus or minus a for us is 10, so 0 plus or minus 10. Now length of the major axis, it's 2a, so that is 20, and 2b, that is 10. And eccentricity, it is c by a, so that is root 75 by 10. This is solvable, okay, because 75 means it's 25 into 3, 5 can come out, that 5 can cut with 10 and you can have it reduced. Then you have the length of the lattice rectum, it is 2b squared by a, so b squared for us it's 25 and a for us is 10. So you have 5 and 5 here, right away you have, so 5 is the answer. Same way we have this, it's of type 1, that's clear that it's of type 1. And how is it? It is like 7 0 over here and it is 0 6 over here. So that way you have your a squared value as 49 and you have your b squared value as 36. So a becomes 7 and b becomes 6. So you have c squared as a squared minus b squared. How much is that? 49 minus 36, which is 13, makes the c value as root 13. So your focus, yes, it's of type 1, so it's plus or minus root 13 comma 0, it's alternating. So maybe you can use that trick over here in the exercise. So then you have the vertex plus or minus 7 0, and then major axis is twice a, which is 14, then twice b, which is 12, and then eccentricity is what is that, c by a, root 13 by 7. And then we have the lattice rectum 2 into b squared, 2 into b squared 36, 2 into b squared by a for us it's 7, so 72 by 7 units, whatever that it comes to. This root 13 by 7. Yes. Then we have this, again it's of type 2, very clear, because underneath y squared it is like bigger value. So you have maybe this as 400, I think it's 20. So 0, 20, and this is 10, 0. Right. So we have a squared value as 400 here, and the b squared value is 100. Like that, you get a as 20 and you get b as 10. And c squared, which is a squared minus b squared, is 400 minus 100 comes to 300. So c comes to root 300. And because it's on the y-axis, so it's going to be 0 plus or minus root of 300. You can solve the root of 300, and this is 0 plus or minus 20. Then you have 2a, which is 40, then 2b, which is 20. Then eccentricity is c by a, which is root 300 by a for us is 20, and 2b squared by a is 2 into 100 by a for us is 20, 10, right? So that way. So that is the first lot of problems. Even the remaining 3 problems are also of that type only, but we are taking it up in the next video. So that's all about the part 1 video. Now we meet in the next video, part 2 video. Thank you.